Scouts! So it's Sarah Hillen again. We are going to be talking this nature study about trees. This is my favorite tree in my yard. I didn't name it, maybe I should. But this tree is a tulip poplar, and tulip poplars have really interesting leaf shapes. So they're 4 points like that. And right about now, in early summer, late spring, they have bright orange and neon green flowers. Unfortunately, all the way up there, so we can't see them right now, but if we do get a rainstorm later, it will knock a few of them down, and they're really pretty flowers. Not something that you would ever imagine having in a tree. I always wonder when I see big trees like this how old they are. And as most of you guys know, if you count the rings on the inside of a tree, you can get an accurate age on how many seasons that tree grew. But I definitely don't want to cut my tree in half just so I know how old he is. And there is a different thing we can do to calculate a very close estimate to how old he is. So what we're going to need to do is take the circumference of the tree, which is how long the tree is all the way around when we hug it. Okay? So you'll need a rope. And what we do is about shoulder height off the ground, about 54 inches. We're going to take our rope all the way around the tree, and this is where the rope ends. So this is the distance of how long my tree is. Its circumference is pretty long. And what I'm going to do now is measure it in inches with a ruler. So 1 foot, 2 foot, 3 feet, 4 foot, 5 feet, 6 feet, 6 feet and 3 inches. And here's where I'm going to do some math. So I know that each foot is 12 inches, and I'm going to multiply that by 6, and I get 72. And I'm going to add the extra 3 inches, and so I'm going to know that the circumference of my tree, the distance all the way around it, if I had giant arms and was hugging it, would be 75 inches. So now what I need to do is find the diameter. The diameter of a tree would be the distance from the outside to the very center of the tree, the very middle of it. And how we find that is by dividing the circumference by a number called pi, which is 3.14. So I'm going to take 75 divided by 3.14, and I'm going to get 23.8 inches. So I know that my tree, if I were to measure from side to side, it's going to be about 26 inches across, 46 inches across, and the diameter is 23. That's just the diameter now, is the 23.8. Different trees grow at different speeds. So the next thing we're going to do is we're going to multiply the diameter of the tree by this specific species growth rate. And I have a book of common trees in Pennsylvania, and in the back I wrote down different species growth rates that I know. And I know tulip poplar's growth rate is 3 inches. Is 3. So we're going to multiply 23.8 times 3, and we get 71.6. That's the age. So we have an estimated age of my tree here at 71 years old. Which is pretty cool. He's an old fella. Alright. Hey Scouts, so we're going to age another tree here. This one is a sugar maple. And again, we're gonna go about 54 inches from the ground to measure. That way we get an even age and the roots don't interfere with our number, okay? So 54 inches is about shoulder height. This is the funny part. Okay, so my end of the rope meets right here. I'm going to hold this mark. And this is how long the circumference of the sugar maple is. So we're going to measure it now. 1 foot, 2 foot, 3 feet, 4 feet, 5 feet, 6 feet, 7 feet, 8 feet, and 3 inches. So, time to pull out the calculator. And 12 inches times 8 feet is 96, plus the extra 3 inches is 99. We're going to divide that by pi, which is 3.14, and we have the diameter of the sugar maple, 31.5 inches. So this guy's even bigger. And I looked up the growth rate for sugar maples. Their growth rate is 5. So they grow a lot faster than the tulip poplar grows. So we're going to multiply 3.15 times 5, which is the growth rate, and we have 157. So the estimated age of this tree right here, the sugar maple, is 157 years old.